Okay, so in this video, we're going to be looking at some basic science terminology that you will use all the time. And then we'll look at how we can improve taking some different types of measurements. So what I'm going to do is we've got a series of different science terminology on the left, and we've got some descriptions that we're going to try and match up to the correct piece of terminology. So these aren't necessarily definitions, they're also some descriptions, but we'll see how it works. So I'm going to work my way down the right hand side and match them up to the correct one. Some of them are matched to the same one. Okay, so a number you get from just one use of your measuring device, which you would repeat to get a better measurement. So something you get from using your measuring device once is called a reading. So if you measure something's length using a meter ruler once, you get a reading of its length. The actual piece of equipment, like in that case the meter ruler we use, is called, the specific word we use is called the instrument. Okay, so the smallest possible division on a scale of your instrument you're using to measure something, with a meter ruler you've measured to the nearest millimeter. Well, that is referred to as the precision. So a meter ruler can measure to the nearest millimeter, so that would be its precision. Something you can improve by making sure to measure as carefully as possible would be aiming to improve the accuracy. If you are not careful, the reading you would get is going to be further from the correct length if we're talking about measuring lengths, so you're going to change the accuracy. Something you can improve by repeating the experiment lots of times. That would also be the accuracy, and the way you'd actually improve the accuracy is you'd calculate an average of our repeat readings, and that removes the little random errors that we get cropping up all the time. Something physical we can measure about an object, like its temperature or its length, that's called a quantity. So temperature is a quantity, a length is a quantity, there's lots of different types. The number you get having taken a number of readings of what you are measuring. So that is what a measurement is. So once you've taken a number of readings, calculated an average, that gives you your measurement. If you repeat readings, do you get a similar answer every time? What you're doing there is you are checking how reliable your readings are. So if they're all close together, they would be. If they're quite spread far apart, they wouldn't be reliable. What you have measured your quantity in, e.g. centimeters, that is called the unit. And once we have a reading, we always write the unit afterwards to make it clear what it is that we are trying to get a reading of. Okay, so that's our terminology that we're going to be using in physics experiments all the time. Okay, so next we're going to take a look at how we can improve some of the measurements that we've been taking. So the first one, we've measured lots of temperatures, so measuring the temperature of a beaker of milk. So what we would do is we would place the thermometer in the beaker and we'd probably stir it a little bit because we want to make sure the temperature is the same everywhere. And then what we do is we would wait a period of time until the thermometer stops. So thermometers, typically the ones that you use, take a period of time to change, so we'd have to wait until the thermometer actually stops at a fixed value. Obviously not waiting too long or the milk starts to cool down and change temperature, but we do have to wait a short period of time. Measuring the length of a rugby ball. So this one is a little tricky. So what we want to do is create two flat surfaces that are parallel to one another, and we want to measure the distance between those two surfaces. So I'll show you what I mean. So I would place a book at each end of the rugby ball, for example, and then measure the distance between those books. Because the problem with a rugby ball is its surfaces are curved, which makes placing a ruler next to it very difficult. By having these flat surfaces, they make it much more straightforward. Measuring the volume of water in a measuring cylinder or a jug. So first of all, I would wait a period of time to make sure the water has settled and it's not sloshing around. And then the key thing is you get down at eye level with the measuring divisions that are usually on the side of the cylinder or the jug to take the reading. And the reason that we're doing that is we're reducing something called parallax error. So a parallax error is when a reading appears different if you're in a different position. So if you look at it from above, it will look one reading. If you look at it from below, it will look a different reading. So we always take it from eye level to make sure we are not introducing this parallax error. Okay, so finally, looking at recording data in a table. So a student's done an experiment looking at falling balls. She used the same object each time, but allowed it to fall from different heights, timing how long it took. And at the moment, the student has been a very poor physicist because we've just got data all over the place. They haven't used a table like is appropriate. So what I'm going to do is I'll show you what this would actually look like if you've done the experiment properly. Okay, so this is what my table would look like for that data we have just seen. So I'm going to take you through the things that I would be looking for in an effective table. So the first thing is your table should have column headings. So all of your different quantities would be arranged in columns like this, and each column would have a heading at the top that tells you what's in the column and the unit that it's measured in. Okay, so we've got there our height measured in meters, our times all measured in seconds. The thing that I wouldn't be looking for is we shouldn't see any units actually in the table itself. They should just be in the column heading. Okay, so the next thing that we'll be looking for is we've got separate columns for the repeat readings here. So each height was done twice, so we've got two columns for those repeat readings, and they're called time 1, time 2. Then what we've got, if you're looking down all the measurements or the actual readings themselves, so we're not looking at the average for now. If you look down a column, they should have the same number of decimal places because these are things we all measured using an instrument, and an instrument has a certain precision, so the data in our table should reflect that precision. Okay, so then the last thing we'll be looking for is if we've got repeat readings, we would use that to calculate an average to try and improve our accuracy. And the average value should all be rounded to the same precision as the actual readings themselves. So we wouldn't have more decimal places here, which some people often do. Okay, so that completes this video looking at some physics basics, the terminology, taking measurements and recording measurements in a table.